Good morning. I'm Dan Hilliard, the editor of Power Materials, and I'm here with Robert Mintak, CEO of Standard Lithium, Andrew Mitchell, the director of nickel research at Wood Mackenzie, and Trent Mell, the CEO of First Cobalt. We're going to hopefully explore a little bit about the power materials sector today, the electric vehicle sector, and what that means for the industry at large. So I'd like to kick off by just saying that electric is the future of transportation. Almost every major automaker has announced at least some kind of electrification scheme on a relatively short time scale. The extant battery supply chain is heavily concentrated in Asia, and more specifically in and around China. So I would put this to the roundtable. Why is it important to develop an alternate, or let's say independent, supply chain for the West?
Who wants to kick it off? I'll jump in right away.
Thank you.
Yeah, no, some of the obvious reasons. I won't dive into all of them, but the elephant in the room, obviously, we've lived through the pandemic and highlighting the critical supply chains and the importance of localizing supply is something that was like a slap in the face for everyone. So understanding that as a lesson learned. And then the other one that jumps to the front is that we're just at the first stages of this new energy economy. So the established supply chains are tight already as is, as you mentioned, focused on Asia, but no one's addressed how we're going to adequately provide the raw materials as this expansion and sort of liftoff happens for EVs and the electrification of transportation. So it's not just about securing supply for the West, it's securing supply for all of the transition that we're going through.
I think it's interesting, Robert. I agree with you about the pandemic. I think it highlighted the whole thing of all of a sudden we can't get stuff and we don't have stuff at home. So how is it going to work? But also, I think the one thing the pandemic actually did is that it's possibly accelerated that electrification journey in that certainly within Europe, a lot of governments have been saying, okay, we're going to have to bail a lot of you companies out because of what's occurred through the pandemic. And part of that is the car companies. And if we're going to have to bail you out, this is a long-term problem of solving the debt issue that we're going to be in. So you need to have a listen to what young generations are talking about, because it's the young generation who's going to have to carry the can for quite some time. And what they're concerned about is the environment, and they're concerned about moving towards electrification. And I think that's actually accelerated the view of governments as well as companies themselves to try and transition much more rapidly. And that in itself is now raising the issue of that security of feed, the ability to get feed. And sort of it doesn't really make sense to be moving bits from Asia all the way across the globe to Europe or whatever, and using all that fuel to do so. You know, it's a catch-22 at the moment.
Yeah. Trent, you're in the midst of a massive new project in North America.
Yeah, I mean, it's a little bit, I was just going to jump on what Robert and Andrew said. It's a little bit like the vaccine race that we're seeing now, right? Canada, the US are well ahead, and you've got the third world scrambling for vaccines. And tragic as it is, that's kind of where we see the battery supply chain going, right? With growth rate, CV penetration growing 20, 25, 28% per annum. The raw material supply chain is going to be strained, and that starts with mineral extraction right through to the cell production. And so, yeah, we're trying to create, or we will be not trying, we will be establishing North America's only domestic source of cobalt sulfate. And we do have chicken and egg problems, right? This is a whole new ecosystem we're creating. And so we've got mines and we've got EV assembly plants, but we don't have the battery piece figured out yet. And so we're a bit of an early mover like Robert. We'll have our refined cobalt, but then we need precursor manufacturing. We need the cathode active material. We need the cell manufacturing. All those conversations are happening behind closed doors as we speak, whether they be with government or whether they be between some of us and people in the industry. The money is coming and it's coming fast. So you got the policymakers fighting for those big investments, the 300 billion or so of global investments into the supply chain. Canada and the US are cooperating to create a North American ecosystem, and they're competing to get those investments in. So it's been fun. We're a little bit early to the game, but the bigger players with the big balance sheets, I think, can catch up pretty quickly.
Do you think realistically North America, I mean, there's not a fat lot in the US. I mean, I know nickel in particular, and there's not a lot that's being done on nickel in the US. There's a number of projects which have been kicking around for a long, long time, and you know, if one looks at the Duluth complex, for instance, you know, there's a lot of nickel there. It's low-grade stuff. It's not going to be necessarily easy to extract, but there's a lot there. But even more problematic than that is the whole environmental issue and the permitting issue. And while I don't necessarily disagree with some of the arguments that are being put forward, you can't have your cake and eat it too. I'm afraid mining is going to have to happen. And in this day and age, it can genuinely be done in an environmentally sensitive manner. Yes, of course, things might happen, but generally mining companies these days are responsible groups, which might sound very strange to some of the people listening in on this. I think in general, they genuinely are. They try very hard to be environmentally sensitive for the most part. There are, of course, areas where it's not quite so simple and straightforward and rosy as I'm trying to paint the picture.
Duluth is a great example, right, of a processing solution waiting to happen. It's a big, rich, mineral endowed area that's, you know, largely, I guess, in the past has relied on conventional smelting, roasting type technologies. And, you know, hydrometallurgy, as we move into an era of ESG, are going to help unlock a lot of these things. Part of it technology, but it's not all that new. It's capital at the end of the day. But I would agree with you, Andrew. There's a lot of projects, not a lot of movement. But you know, I used to work at Barrick 20 years back, and we got out of the game of early stage exploring. We left it to the juniors. And so we're in this unfortunate cycle of boom bust, right? Boom times we all put our shovels in the ground and or at least start drilling and trying to advance it. But it's only once you get sort of past feasibility and sometimes into construction when you get the balance sheets coming in and giving you that backstop. But what I've noticed really changed in our industry from my start over the last sort of 20 years is this evolution from CSR to ESG. So it's not just, you know, doing good by the community and health and safety, it's quantifying your footprint. And that has really focused the attention, certainly our attention. And our mandate is to produce the most sustainable cobalt in the world. And that's both by where it's sourced out of the DRC, but also how it's mined and the carbon footprint. And I think that's going to help some of the better projects rise to the top, even if they're small, right? Because if they're small with a low carbon footprint, I think society is going to want to see those go forward.
Yeah, the conversation between stakeholders in the extractive industry and then the end users is being reset from typical extraction industry where it's not necessarily providing the supply chain for an energy transition. So this is a new sort of lens that you have to look at it. If your principal reason for adoption of EVs is to work at mitigating climate change and also the renewable energy transition and the supply chain needing to, you know, walk step by step along with that, that is unusual, or it's new for the extractive industry. For oil and gas, it didn't exist, that clean supply chain necessarily to get it built. And the same with other commodity metals, they don't have the narrative that you have to address. So that will that conversation is underway. So stakeholders, the NIMBY sort of challenge that greenfield developments face, those are, it's still such an early era, early in this new era that things will change. There has to be some examples set, you know, communities won't trust us from mining companies. We'll do good, we'll do better. We promise, you know, we'll exceed your expectations. You have to demonstrate that. So there'll be winners and losers along the way. The transparency in the supply chain that's being sort of mandated from governments as well to show the carbon intensity coming out of Europe and others will force either, you know, the traditional in areas and geographic locations where mining is done to step up their game, or areas like North America where it's a challenge to build will have to communities will need to participate in the supply chain. We've taken the approach on our project. We've looked at hundreds of lithium projects that have failed over the last decade. There's been only a handful of successes in the lithium space, primarily Australia, and they do mining very well there. In North America, we haven't seen a lithium project built in almost 60 years now. So we looked at, when we started our project, and said, we don't want to do any of that permitting. We don't want to face any of those challenges. We want to build something. So that's why we chose the location and project we did, because it was already brownfield. So that was a conscious decision to avoid the challenge, but we're still so early. We're not even at the starting line yet in this industry. So
In
It's an
terms of
interesting quandary,
timelines,
isn't it? Sorry, Dan, it's just on that, and I know we're going to move on to batteries later on and the cost of batteries and things, but it's an interesting situation in that if you look at, again, nickel, because that's what I know about, if you look, there is nickel around the world. There's plenty of it. The question is, when you start to utilize an ESG mapping, if you like, and then you start to narrow down what may be acceptable and available to the West rather than China, and I don't want to sort of be bifurcating between the two per se, but if we are going to get strong on this material has to be environmentally and socially responsible, it certainly starts to narrow down where you want to extract your materials from. And likewise, it probably then puts a capital burden on the cost of developing that, as well as possibly an operating cost, and therefore you need higher metal prices. And likewise, does that mean that the ultimate consumer is going to be prepared to pay more for my green car? It's a real catch-22.
absolutely. And as with so many things, price is paramount. This was a question that was posed to us slightly before the webinar. How can battery prices ultimately come down, which will be important for price parity with fossil fuels, if raw materials keep going up? What does that timeline look like? Will there be a tipping point when supply and demand balance? And if so, when? How do you see the markets developing for your individual products?
I think what we've seen thus far is a lot of the efficiencies that are being captured. It's the learning curve, right? It's manufacturing at scale. It's learning how to make materials more efficiently, learning how to reduce battery scrap rates. The unfortunate thing for this industry, perhaps for the downstream, is that the battery materials miners and refiners are not willing to enter into fixed price contracts. And certainly in the cobalt market, which I can speak to quite a bit, there's been some hand wringing on the efforts of some OEMs wanting to lock in long-term prices for the commodity, and we can't do that. And so I don't think you can look easily, at least, to the cobalt price, or to a fixed price to kind of solve that for you. Now that may differ, I suppose, if you're getting involved at the asset level and doing prepayments and offtakes of a more strategic nature. But from what I've seen, it has more to do with volume, economies of scale, and the production process.
And additionally, the battery, we're benefiting from China's 10 years of early adoption in the EV space. So the investments being made by the Western OEMs, they get that decade of trial and error that's gone underway, so that the models that are showing up in showrooms will be at a much more advanced battery technology state, but it's still, we'll be seeing energy density improvements and other next generation batteries that'll address a lot of the challenges that the power to the ratio of the battery to efficiency in the vehicle, that'll with economies of scale. And then also what the consumer wants at the end of the day today may not be the same car in 2030. As Andrew mentioned, we're building these with the mandate that the next generation coming along is demanding cleaner efficiency, and we're to move away from the 20th century technologies that were still driving the economy. So it may be that batteries and EVs and the way we use transit and transportation evolves additionally. So smaller cars, car sharing, all of those things, we don't know how it will all shake out at the end of the day. And India and other countries will have a different consumer focus than the middle America. So it's assuming that what we're looking at from the, looking in the rearview mirror of what we wanted and what we needed isn't necessarily what will fall or what will happen in the next decade and following.
That's an interesting point. The culture seems to be evolving rapidly in terms of autonomous vehicles, electric vehicles, and even hydrogen has a part to play, let's say, in trains and long distance transport. Andrew, on the nickel pricing, how does matte play into that? Is the nickel market fundamentally changing as a result? I know that now nickel is being drawn from the traditional markets, the stainless markets, and increasingly into the EV space. Could you talk about nickel pricing a little bit?
Yeah, I mean, the matte situation with Indonesia was a very dramatic event, shall we say. It was something that we had highlighted would be announced sometime this year, not necessarily by Tsingshan, but we knew people were working on converting nasty, dirty nickel pig iron NPI into nickel matte for batteries. But the market was essentially ignoring it because it viewed it as a class 2 product, and you need class 1 for batteries. Let me just point this out right away. You do not need class 1 nickel for batteries. You just need nickel in whatever form. It's just a question mark of how you turn that into nickel sulfate of a sufficient purity to make it into a battery. It all comes down to economics. And the view was that all this NPI investment in Indonesia, which has been unbelievable. I mean, we have never, ever witnessed growth in nickel production of this scale ever. Even the Chinese NPI revolution is being totally overshadowed by what's happening in Indonesia. It's staggering. So anyway, the whole point was that Tsingshan announced the largest stainless steel producer in the world, and probably the largest nickel producer in the world if you look at what units it controls. They announced that they were going to produce nickel matte from nickel pig iron, and that really put shockwaves through the market. Everybody, the price dropped, I think, 15% in 2 days. While everybody was just happy to watch the price go up and say we're short of nickel for batteries. All of a sudden this meant we're not short of nickel for batteries if this can be done. And in reality it can be done, and it has been done for ever and a day, well not every day, but for a long time at PT Valley in Indonesia. They have taken laterite ore, made a nickel matte. So it sent shockwaves through the market. But I think there's no question that prices are probably at a level which are sustainable right now, but they do need to be higher if we are going to see greenfield investments outside of Chinese investments in Indonesia and China itself. There is if one wants to be cynical about it, China has done what China needs as a unit to secure what China requires for its electrification and its stainless steel development and its broadening of its economy. While the West have watched on and gone, goodness me, how can we compete with that? Well, actually, you probably can't compete with it, but China's just trying to support China. The West needs to do something for itself and we come back to project development and the Duluth complex, et cetera, et cetera. It's a circular argument that we need to start to see investment in nickel projects, but we are too focused on a short-term return of quarterly dividends when mining is a long-term business. You cannot run a mining company on quarterly dividends, and shareholders becoming upset by this. And I'm sure that's going to sound controversial, a bit sort of soapboxy, but I genuinely believe it. You have to look at a project, and yes, it's going to cost you $2 billion to build it. Hopefully that $2 billion is enough to make it work successfully, and ultimately you will get the returns. So we need our view is certainly we need higher nickel prices long term than we currently have to incentivize that investment, or at least a perception of higher prices, because ultimately what happens is that suddenly the price goes higher, everybody builds projects, and then the price comes down very rapidly. But EVs, it's the growth area in nickel. Stainless is still the largest consumer of nickel. It will probably continue to be so for a very, very long time. But EVs are the growth area, and we do need to start to see project development if we're going to maintain the required supply for security of feed domestically, if you wish, but also in terms of a global electrification journey that's required. In terms of current battery chemistries, I mean, obviously, as Robert said, things will change and will improve in terms of efficiency, etc. But it's going to need to happen.
What does the recycling picture look like long term? Obviously, this is a much longer term view, but there have been some announcements that you can recover up to, say, 90% of the materials from the black mass of recycled batteries. Do you see that evolving step by step with mining, or do you think that it will come later on as a auxiliary process?
I definitely see it coming in parallel. So for us, we're going to achieve first production from our cobalt refinery, producing a cobalt sulfate next October, so the Q4 of 2022. But within a year to 18 months of that, we would hope to be producing battery grade products, now not just cobalt at this point, but nickel, copper, and hopefully lithium from black mass. And why? Because there's not a lot of material there, frankly, in North America. It's a small market, but the trajectory is quite strong. But we're a hydromet plant. It's a leaching operation. So whether you take in black mass, which is just a powdered form of material, high grade, you can leach that as well as you can leach a cobalt hydroxide. So for us, it's an obvious add, and the margin opportunities are huge there. Nobody's doing it in North America particularly well. More and more people are looking for solutions, including our partners, right? The OEMs need to figure this out. They don't own the battery, but they'll own the problem if we don't figure this out. So in addition to battery scrap at their plants, end-of-life batteries need a solution, and this is the right time to do it, because the batteries that we're playing with, if you will, experimenting with, are our phones and our laptops, and they happen to have a lot of cobalt, which is the most valuable material. So as we now move into an era of high nickel with the long range batteries, then you're getting the tonnage, but the value on a per ton basis is not quite as strong. So if you can perfect your technology on a small scale now, and the technology is not that complicated, then you're ready for the onslaught of bigger materials at 5 and 10 years out.
Yeah, it will play an important part, but it will be very incrementally based on supply of batteries coming into the secondary market or being returned for scrap, and then also relying most likely on government incentives to underwrite that initially. The challenge on lithium, I mean, cobalt and the other other metals in the battery will be easier to recover. The challenge on final product, though, just to qualify a lithium carbonate or a lithium hydroxide to a supply contract can be 6 to 12 month exercise to show you can produce not just weekly or monthly, but every delivery meets the criteria. So starting with a product that may not necessarily, and I don't know enough about the recycling chemistry, but just knowing that the qualifying criteria for lithium to a supplier is getting more and more strict. So how that product is produced and then delivered, secure supply, that will be something that will be based on what's the easiest to recover. The recycling industry, the way it looks now, is it will kick off with taking the waste or the non-grade materials coming out of the battery factories and reprocessing that. That looks like the contracts that are being secured, but it will probably be top-down driven from governments mandating, just like they do with other recycling, that there'll be a cost associated when you buy a vehicle for the recycling element that will go back, and that will allow for sort of equalization on bringing it in. But I don't think it will impact the critical raw material supply chain this decade at all, because you got at least an 8-10 year battery life in a vehicle, and there's only so many cell phone batteries and others. It's such a small volume that it would have a negligible impact versus the cost associated with with trying to create a supply chain from that. So not this decade, I don't think you'll see an impact.
I would agree with you, Robert. I think we do view it as something which is going to be absolutely necessary, because as part of the supply chain, there's no question. You can't just dump the battery and it's done. It doesn't make any sense at all. It's going to be an absolute necessity, not just for batteries, but for all sorts of things that we currently throw away, to be brutally honest. But yeah, in the next decade, I think, what do we have? About 100,000 tons of nickel coming back as secondary materials in a 3.5 million ton market. At that point, I think it gets to about 6% or so by 2035 of the total supply. So it's not huge, but without that, it amounts to something like 300,000 tons of nickel, and without that 300,000 tons, we are in potentially in a significant deficit market, which obviously you can't really have, but it means that we are short of material in order to maintain a balanced market and to provide the materials that are required for the continuing EV journey.
And it'll significantly lower the ESG footprint. Sorry to cut you off, Dan, but I think that's where the win. Because I agree with both of you are saying that lithium is going to be a hard one to get out of the battery. That's why I was cagey on that one. Nickel, copper, cobalt, yes, and I agree with Andrew that the contribution to the ecosystem is going to be pretty small, but it's important. And what it can do is it'll drop your ESG, your carbon footprint on a battery cell by at least half if you're able to put that back into the ecosystem. So from a sustainability perspective of the OEM, I think it's a real important contributor to your bottom line ESG metric.
If I can just be slightly controversial here, and I probably won't win myself any friends, but
always,
it's an interesting thing in terms of recycling, because if we think about it, at the moment, Congolese cobalt is being shunned somewhat because of the perception of the way it's mined and things. We are going to get Congolese cobalt coming back for recycling.
Yes.
What are we going to do with that? And okay, we'll have the blockchain maybe to recognize that that's where it's come from,
yeah,
but it's already there. To my mind, I think we have to use it. We do have to use it. It seems crazy not to. And hopefully, by the time it comes back in 10 years' time, perhaps more things will have been done within the Congo to rectify the problem rather than the situation, if you see what I mean. But it does pose an interesting quantity. That's something that might have had, let's take Indonesian matte going into China, creating batteries. As batteries come back through, so it's got a high CO2 footprint. It's got nothing to do with child labor or anything like that. But we're not going to throw that nickel away. It has to be reused. It's madness not to put it back into the system.
Yeah, you wonder how you reset on the carbon footprint piece for that reason, right? If you're getting not all nickel is going to be made the same. On the provenance issue of the DRC, that's certainly something front and center for us. And so I see that, and it doesn't address your whole issue, Andrew, because you raise a valid point. Blockchain is going to be helping barcodes, right? I mean, the three biggest and reputable minds in the DRC are going to be collaborating on a blockchain initiative. We intend to follow that so that we can deliver to our clients something that's certified as ethically sourced. But once it gets recycled, you would probably attach that to a battery to some extent. But there is still going to be cobalt out there that predates any of these initiatives that's going to be tainted, right? And so there's a bit of a reset almost. I don't want to call it a leap of faith, but I think there's a go forward solution. It doesn't solve for the blending issues that we've had in the past.
Yeah, it's just one of those. If you have very strong opinions about the situation, maybe in the Congo or CO2 footprint, that perhaps it's destroying that ethos. But say it's a bit like energy storage. Actually, if you think about energy storage, lead acid batteries are really good at energy storage. We're taking all of those lead acid batteries out, we're closing recycling centers, so we're having a lead battery mountain. What the hell are we going to do with all those lead batteries? They're just going to end up in a hedge somewhere and discarded.
Legacy. Yeah, legacy issues are going to be an evolving issue on all front. And even with the fossil fuel vehicles themselves, steel is infinitely recyclable, so that's less of an issue. But the the rubber hosing, all the so-called fluff in recycling scrap. That's going to become an issue, at least on the steel side as well. I wanted to build on something that Trent said real quickly. I also want to remind all of our attendees that you can fire off questions to us while we have the speakers here. Please take that opportunity. We have the big guys represented: lithium, cobalt, nickel. Are there other battery materials that you see as either bottlenecks to battery production or possibly in supply glut? I'm thinking here of the rare earths, copper, manganese, assorted things. And how does that tie into evolving battery chemistries?
Andrew, you go.
Everybody's taking a step back for the microphone here, aren't they? The battery chemistries are developing, I think, very rapidly. There's no question about that. We've gone from LFP to NMC 111 and 622 and 811 now. The work will continue to develop batteries. I mean, I'm not familiar with all of the chemistry, but there's zinc air and things like that which have been looked at, and we will see different battery chemistries being developed. I don't think there's any question about that, and there will be a trend probably towards higher energy densities and lower usage of metals if possible, all of which is aimed, of course, at lowering the battery costs ultimately. But exactly what metals are ultimately going to end up being used? If it's rare earths, we're all in trouble because China controls 60 or 70% of the rare earths production. So that's going to be even more difficult than nickel, cobalt, and manganese and lithium.
Yeah, and copper obviously is making a lot of headlines. And it's not just to do with EVs and batteries, it's the entire electrification. The recycling aspect is already very advanced there, but copper is one that really, I think, it was identified, at least several presentations I saw from battery brand names, I won't mention names, identified it as the most critical metal over the next 30 years for them. So not immediately, but in 2040, 2050, copper was going to be the priority for them. So lithium, there's lots on the planet. You need to be able to extract it, purify it, and make the material and get a project built. And it's not been something the industry's been successful at, but copper was the one that really had for a long-term impact on the supply, was the one that was the least manageable.
Interesting. Nickel is always called the devil's copper, and I always like to think of it the other way around, that copper is the devil's nickel, because it always outshines nickel somehow, and every time the price looks like it's going to collapse, the Collahuasi mill breaks down and the copper price recovers rapidly. I would agree that copper has the potential to become constraining, but there are interplays obviously between copper and aluminium in terms of transmission, depending on the price. I don't know exactly how that works, but I know there is. And you're right, copper is very widely recycled. It is relatively straightforward to recycle. So I think that's where copper will come into its own, is that you will be getting a lot more copper coming back into the system than perhaps right now we do see.
So Dan, I think it really comes down to decarbonization and the amount of metal that's going to require as a global economy, right? And I think as a society, we're going to have to confront our NIMBYism, and the only way we're going to decarbonize is to extract more minerals. There are a lot of minerals in the ground. They're not all economic today, and they're not all accessible. And by that, I mean that the permitting regimes that are in place in most Western countries are pretty exorbitant. 5-10 years to permit a mine is not tenable at the pace of change that we're undergoing today. So I come back to that. I mean, rare earths, there are opportunities in North America. It's bloody hard, but it can be done if the willpower is there. And we're starting to see Department of Defense get behind it. I think the Canadian government's looking at it as well. But it's time, it's effort, but I think more than anything, it's got to be a collective will to want to see that happen.
Yeah, and it's going to have that government backing. I agree. This is really where, to me, China has been so successful, is that, yes, okay, it's companies doing it, but it has the backing of Mother China to secure materials and do what China wants. Whereas we've been a bit disparate in our modus operandi, and certainly it seems to be coming a bit more together. Thinking about the way North America is talking about security of particular materials, Europe is certainly talking about the same thing and trying to ensure that not necessarily to become self-sufficient, but that we're not wholly reliant on elsewhere to deliver the goods, and that we know where this material is coming from. And ultimately that must be good for the economy. It's while we're putting all these constraints on where material can come from, actually mining and the economy and the electrification economy is going to generate jobs, it's going to generate money, and ultimately that's got to be good for the whole package.
On the policy front, we've seen in certainly over the pandemic, but increasing pace afterwards, announcements about the end of fossil fuel production for vehicles, the end of fossil fuel vehicle production rather by 2035, complete net zero in some areas by 2050. From a policy standpoint, but more importantly from your guys' materials standpoint, is that possible? Is that timeline feasible to have by 2035 no more fossil fuel new vehicles produced? Will there be enough batteries? Is that a bottleneck?
It's a pretty rosy scenario to think that the supply chain, it's 14, 15 years from now, seems like a long period of time, but just understanding how long it takes to create, build, that supply chain, 4, 5, 6 times current production of some of the critical minerals, lithium and others, unless there's a massive mandate and underwritten support for the industry. I don't see it being an achievable target. Additionally, and I'm extremely invested, and the reason we got into the space is because of the opportunity, and looking at this as a new sort of industrial revolution, it makes a great investment case to be part of that supply chain. But the end user and the final manufacturers haven't really looked out and seen where the supply chain for those is going to be developed. So it's one thing to announce 80, 100, $300 billion worth of investments on the shop floor for EVs and the batteries, but unless you've got a complete, from end to end supply, production, and right to the showroom for EVs for the product that consumers want, it's a false narrative that can be created there. So putting policies in place ahead of implementing the elements to make them successful is setting yourself up for failure.
I'm invested in the space as is Robert. I love my EV, but yeah, I got to call it. I don't think it's possible to get to 100% electrification. It's going to take a massive amount of materials. So we're either going to lower the percentage of people that own vehicles, or we're going to have to quadruple the price of vehicles to get there, because there's just not enough material to get us even to a 30 or 40% penetration rate at this point in time. It's going to be quite a push.
It's certainly a challenge. It's going to require, I mean, from a nickel perspective, let's assume I'm permitted and I've got the money today. It's going to take a 3-year build, maybe 2-3 years, and then it'll probably be a 5-year ramp up to capacity. So it's 8 to 10 years away already before we start to see a 30,000 ton nickel project developed. That's outside Indonesia, where they're putting projects up like it's going out of fashion. But in the West, that currently is what it's taking. So realistically, to get the stuff to make the batteries to move us away from oil, it's going to be a monstrous challenge under current battery scenarios and battery chemistries to get anywhere near that. I think you're right, Robert. By setting those targets, it is setting yourself up to failure. But in many ways, I guess if you don't have that target, you're never going to aim for anything. So I agree, it's going to fail, but at least there's something to aim for. You know, it's.
Yeah, absolutely. I didn't mean to come across as.
No, I didn't take it that way either.
It absolutely, when you set at least the target, it's just whether if you force that, it could, and the transition from moving, consumer options could come back to haunt us. I tried to be unpolarizing with regards to fossil fuels and the oil and gas industry. EVs require petrochemicals. I mean, there will continue to be a petrochemical industry. So that aspect and others, it will be moving in big steps, and then take a pause and understanding where the industry exists. Changes in governments will also impact that, but from a industry perspective or from a developer's perspective, it's extremely attractive for us right now. So to be a first mover, first producer in the industry, and primarily my audience is typically investors. It's an extremely opportunistic time to be participating in this transition. So we're moving away from the legacy energy industry or the heritage industry and being part of this. Extremely exciting times, and I'm just very happy I've kept the lights on to experience this now.
Yeah. There's over the last couple of years, particularly during the Trump administration, there was an issue in steel regarding safeguarding and tariffs. Do you see something similar, some kind of protectionist scheme evolving in the US or in other Western countries regarding sort of a protection of its battery materials industry from the established players in China, Indonesia? Do you see something similar to the 232 being applied to battery materials as a national security concern?
I see a few things going on. One offense and one's defense. I think the defensive posture is just being ready for the, I guess responding to China's just preeminent position in the battery space, and recognizing that they could do that to America, right, and block us off from the materials we need, as has happened in rare earths in the past. So I think there is some movement afoot to try to ward that off. But under the Trump era, we also saw a series of Chinese tariffs that went up. So you're importing cobalt sulfate from one of our peers, competitors out of China. You're facing a 30% barrier, tariff barrier today. So it gives us a huge competitive advantage to anybody who wants to buy domestically that particular product. The other thing that I'm seeing out of Europe, certainly, and I think it's going to come in Canada, I'm not sure about the US, is just going to be a carbon tax, a carbon border tax. And part of that's going to be the carbon footprint of the material. There's also the recycling content. Europe is going to mandate, I think it's 2025, correct me, gentlemen, by 2025, I think they want to see 12% recycled content in their batteries. Canada's looking at that as well. So there are a whole bunch of different sort of stick as opposed to carrot approaches, I think, that's going to try to create a nascent industry here on the continent.
Yeah, the scenario with the tariffs, I think it would negatively impact where we are today in the sector, as well from a North American or even a European perspective, because there isn't an industry to protect upstream at the moment. So unlike steel, which is 100 plus years of the steel industry, or 150 years of the steel industry, you don't have an industry to protect today, and you have the big names in the EV space who would be, they would be impacted not being able to have access to supply. So until the industry is actually not in its infancy. We're not even in our infancy yet. There's nothing to protect at the moment.
Yeah, I think that's a good point. The carbon tax is proposed, certainly. Whether that's really going to be enforced hugely remains to be seen, because it would, right now, as Robert says, there's nothing to protect. So we have to be careful about cutting off our nose to spite our face here. It's certainly in stainless steel, the 232 thing really penetrated across the world. Basically every stainless steel producing country hates every other stainless steel producing country right now, and there's tariffs going up left, right and centre, and safeguarding duties, most of which is really against Indonesia and China, because of I mean, it's being produced so cheaply, genuinely. So it's not dumping, it's actually being sold at a margin. It's not being dumped. So it feels a bit harsh to do that when again, we in the West have sort of sat on our hands and not invested, to be brutally honest. But no, for now, I don't see that we can realistically put in any safeguarding measures. Ultimately, as the industry develops, maybe it will.
Yeah, I think sort of the inverse, or the alternative policy would be incentives for localizing supply. So, well, without curtailing access to markets, but incentivizing tax credits or other mechanisms that incentivize the localization. So without using necessarily the carbon aspect, but other forms of policy levers that can direct this localization of supplies, and then also, which the fallout being more jobs and shortening supply lines being a benefit. I think that would be the best or most sustainable approach for policymakers, as opposed to tariffs, until the industry has been at least gone through the first iteration of the development that we're about to see.
Good point.
And I probably already know the answer to this, but ahead of the poll, I wanted to ask you folks if you believe that hydrogen is a complementary or a competitive product to batteries. Do you think there's a place for both in the transportation economy, or will one ultimately win out as a transportation drivetrain of choice?
I think the battery is already pretty much, at least in the EV sector, there hasn't been a seismic shift in investments that you're seeing with gigafactories or mega factories. No one's delivering on those. You're not seeing, other than Honda and Toyota, anything in the hydrogen, I think, or maybe, and then one of the Korean models where everyone's already, either talking about or, pulling the curtain back on their EVs. And you don't have, as much as he's polarizing, you don't have a figure like Elon Musk, which really drives, the sex appeal of batteries. So
Right.
Hydrogen will have its place, but unless you find someone like an Elon Musk that really is a tall tree that drives the adoption, it'll be a hard sell.
Yeah, I think they're going to be complementary. There are ways of generating green hydrogen, and it may well become more prevalent than it currently is. But rather like, batteries moved on from LFP is still going to have a place in batteries, I believe, for quite some time to come, because it's perfectly suitable for buses and forklift trucks and what have you, where you don't need to have a range and you can stop off and charge it. So you don't need to get nickel and cobalt involved in those particular aspects. There will be instances perhaps where hydrogen is preferred for whatever reason. I can't think of anything off the top of my head, but and you'll still have to overcome the public perception of safety, as always with hydrogen. I mean, you still do to a certain extent in batteries, I guess, but I think most people's concerns with batteries and electric vehicles is, can I drive 400 miles without stopping? And the answer is no, not necessarily, or at least in very few models can you do that. And they're very expensive. But how often do you drive 400 miles in one go? You often stop off to get a cup of coffee or whatever. It's then a question mark of, can I charge my vehicle within 15 minutes while I go to the loo and I get my cup of coffee? We're all panicking about those distance issues, where realistically we need to change our mindsets and not worry about it too much. You know, I don't have an EV, sadly. I wish I did, but and I wouldn't want what would be a 4-hour journey to end up being 6 hours because I have to be stopping every couple of hours for a half an hour recharge. It just gets tiring and tedious. But I don't do it very often, so maybe actually it doesn't matter. You just change the way you do that journey.
Well, I could do a 6-hour drive with about 30 minutes of stop time, so that's not bad in my EV. But I think hydrogen, there's a place for it, but it feels to me from everything I've seen that it is niche-y, right? It's going to be, you need the fueling stations, right? It's going to be localized areas, maybe a port, maybe a bus fleet where you've got access to the infrastructure. But as Robert indicated, the EVs are just so far ahead with the hundreds of billions of money going into the supply chain. It just doesn't make sense to replicate that on a global basis for hydrogen. So I see it being used in certain areas where the infrastructure supports it and where the resource is available, but I don't see it as a competitor, but yes, complementary.
Excellent, thank you. And before we wrap up, I do want to have a short poll for our attendees. So if I could we bring the poll up? As battery prices continue to fall, when do you predict electric vehicles will reach price parity with fossil fuel vehicles? 3 years, 5 years, 10 years, or never? Again, that's as battery prices continue to fall, when do you predict electric vehicles will reach price parity with fossil fuel vehicles? 3, 5, 10, or never? We'll let that go for a minute or so. And got some results rolling in. Okay, collecting responses. Excellent turnout, more than 70% voted already. Okay, let that go just a little bit longer, another 5 seconds or so. All right, and the attendees, it looks like the bulk of you say within 5 years, electric vehicles will reach price parity with fossil fuel. Close second, 10 years, 3, not very many, and not insubstantial portion say never. So I want to turn back now to our panelists and get your reaction to that. As folks that are sort of the first movers within the battery materials industry, what do you take from that?
I would go back to, Bloomberg does a good job at tracking, right, the cost per kilowatt hour of the battery. And I think when you go back, I don't remember how far, that goes back over a decade, it was $1,000 a kilowatt hour and going down now to 100, and I don't know where we sit. Maybe it's 120, 110, and $100 is kind of viewed as that point in time where it's widely believed we hit that parity. I don't recall their projection, but I would have thought it's in that 3 to 4, 3 to 5 range. So I'm relying on third-party data to get there, but we're certainly seeing the cost of the battery pack come down significantly.
Yeah, it's also addressing what is the consumer, the criteria for what vehicles you're trying to compare with as well. So with where we sit in the market today, it is, a luxury vehicle, almost all EVs. So depending on how you qualify a luxury vehicle, if it's north of $50,000 US, then the EVs are luxury vehicles. But that had to be driven to get the practical aspect of it was make something that people who have the money to be able to afford can get that vehicle on the road. And now we're seeing, if you don't need all the self-driving features, depending on, the only elements that really are different are the battery on an EV. You lose the transmission, the radiator, all of those cost inputs. So as the battery prices come down, you can address the final product, based on consumer criteria. And as Andrew said, LFP for batteries in buses, but also depending on where you are in the world, with an LFP battery, they're getting 200 to almost 300 miles range with some of the new LFP blade chemistries. So that may be a way of also bringing the prices down, and based on what consumers are after. It's not always, the F-150 Lightning was announced just recently. That is the top selling vehicle in North America, but it may not be what people need in Italy or in the Middle East. So I think it's a question that is topical, but absolutely the parity will come. It just depends on what your apples and apples or apples and billiards balls. So it depends on what you're comparing.
I would have been going for the 10-year time frame. I have to say, I think towards certainly the back end of 5 years and into the 10-year time frame. There's no question they have been coming down. They will continue to come down with economies of scale. I think a lot of the cost of certain vehicles anyway is in part the battery management systems themselves, because certainly with 811 type chemistries, there is that potential, should we say, for thermal runaway. So you have to be cognizant of that and control each of those batteries to ensure that they don't start to misbehave. And it's all well and good having a phone setting itself on fire in your pocket, but if a car starts setting itself on fire, then it's a bit more difficult. And and having that battery management system obviously can control that, adds to the cost of the vehicle. So I guess as the battery chemistries themselves become more stable, one hopes, then it takes away the necessity to have those control systems, expensive control systems, and it starts to reduce the cost of those vehicles. And we'll start to see a second-hand market, and that'll be quite interesting to see how that develops in terms of really how long have I got in a battery life. And I don't think we really know yet. We all say 8 to 10 years, but we don't really know how long those batteries are going to last in terms of their charging life. And even at the end of 10 years, is it just the fact that they take longer to charge, or they will only go 250 miles instead of 300 miles? And actually, is that okay?
Excellent. And guys, we're rounding the hour, so I would like to take this opportunity to thank all of you for your participation. We've heard some great stuff today and got some great insight. Thank you again. And to our attendees, thank you for attending the event. I hope you learned something. Please remember to subscribe to a free trial of Power Materials, and ultimately, hopefully, subscribe. And we'll see you next time at our next webinar. Thank you. And thank you to our presenters again.
Yes. Thank you
For hosting, Dan. Thanks.